Hi everyone. Now I am going to discuss the lecture number 3 from motion in a straight line. I am going to discuss about the relative motion in a one-dimensional motion. Relative motion, just to explain detailedly about this, I am taking a reference point at x is equal to 0. A reference point is there at x is equal to 0. From this reference point, I am taking two objects are there, like object A, object B. Let us consider that object A position from the reference point is, let us consider xa. Let us consider the value is 10 meters. Now I am taking one more object which is located at B point. That position I am taking xb is equal to 20 meters. Now you can see what is the meaning of position of A. Position of A with respect to origin. We can write xa is equal to 10 meters. Similarly, position of B with respect to origin, we can write xb is equal to 20 meters. If I want to calculate the position of A with respect to B, see, with respect to B is 20 meters, A is at 10 meters. Now B feels that A is at 10 meters shorter than that. So I can write it as position of the A with respect to B can be written as, now B is feeling that A is at 10 meters shorter length is there, no? That way I am writing like a position of the A minus position of the B. If you write that 10 meters minus 20 meters, you will get the minus 10 meters. Now similarly, if I want to calculate the position of B with respect to A. Now position of the B, A feels that B is 10 meters ahead. Okay, so we can write it as position of the B with respect to A can be written as position of the B minus position of the A. Position of the B is 20 meters and position of the A is 10 meters. Finally, we will get the 10 meters. So what I am going to tell is, if you want to write the relative positions or relative velocities or relative accelerations, meaning is just we are comparing. Okay, B is feeling that B is like 10 meters ahead of A. A is feeling that actually 10 meters shorter. Otherwise, you can say B knows that A is less than B distance, and A is knowing that it is less than the B, and B knows that it is 10 meters ahead of the A. Okay, that we are going to write now. So finally, what I am going to tell is the relative position of the A with respect to B can be written as relative position of A with respect to B can be written as xab is equal to xa minus xb. That's all. Now if I want to calculate velocity of relative velocity of A with respect to B, if you want to calculate velocity of A with respect to B is equal to d by dt of xab. What I am calculating is instantaneous relative velocity. We can write it as VA minus VB, you can write. Similarly, relative velocity of B with respect to A can be written as VBA is equal to VB minus VA. We have to write with vectors. Actually, in the vectors also I will give how to write that. Later I will write. Anyway, they are moving in straight line. According to the right side, left side, we can write and we can follow that. Okay. Presently, if you want, we can write the VA bar minus VB bar. Here also VB bar minus VA bar we can write. Similarly, relative acceleration of A with respect to B. We can write velocity acceleration of the A with respect to B can be written as A with respect to B can be written as acceleration of the A minus acceleration of the B. That's all. This is only actually concept. In throughout the relative motion, whether it is one dimension is there or two dimension is there, we have to see only this part only. Understand that? Later, detailedly, in case of the two dimension relative motion, in two dimension, I will explain with vectorically properly. But in one dimension motion, that much is not required. For example, I am giving now. See, next page I will give. Let us consider A. A is moving with like a VA is equal to 20 meter per second. B is moving with 10 meter per second. Both A and B are moving in same direction. If I want to calculate velocity of A with respect to B, I can write it as velocity of A minus velocity of the B. Velocity of A is 20 meter per second, right side is there, minus velocity of the B is 10 meter per second, right side is there. Both the directions are same. I can write it as 20 minus 10 is equal to 10 meter per second, right side. Now, velocity of the A with respect to B, nothing but B is feeling that A is approaching. With what velocity it is approaching? 10 meter per second. So, if you want, I am writing B feels that A is approaching with 10 meter per second towards B. That is the meaning of this. Same manner, if you want to calculate velocity of the B with respect to A, velocity of the B minus velocity of the A. Velocity of the B is 10 meter per second, right side, minus velocity of A is 20 meter per second, right side. I can get the value is 10 minus 20, I can write as minus 10 right side. Minus 10 meter per second, right side. What actually minus 10 meter per second left side is there? Actually, you can see the same thing, you can write it as 10 meter per second left side also you can write. Okay. Now you observe carefully velocity of the B with respect to A. B feels that B with respect to A feels that B is moving with what speed? 10 meter per second towards this. Why? Reason is this minus sign indicates that it is having less speed than the A. Understand that B is having less speed than A. So I will write like A feels that B is approaching with 10 meter per second towards A. Nothing but A is left side is there, no? That's why B is approaching towards A. That like that it is feeling. So you can say that the separation is obviously reduces in the both the cases, separation will reduce. Understand that? Next case, I will give the one more thing here. If they are moving opposite direction, VA is equal to 20 meter per second and B is there which is moving with 10 meter per second. Both are moving opposite direction. In this case, velocity of A with respect to B can be written as velocity of A minus velocity of the B. Velocity of A is 20 meter per second right side minus velocity of the B is there 10 meter per second left side is there. If you see that one is right side, other one is left side is there. What will write? 20 meter per second right side. So left side is there, that's why I'm writing plus 10 right side I'm writing. So you can write it as 30 meter per second towards the right side. You can see that B feels that A is coming with what speed? B feels that A is approaching B with 30 meter per second. Okay, at faster rate it is decreasing the separation. Okay. Similarly, if I calculate the velocity of the B with respect to A, velocity of the B minus velocity of the A. So you can write velocity of the B is 10 left side is there minus 20 right side is there. we can write it as 10 left side, and minus 20 I can write it as plus 20 left side I can write. So overall I can get the 30 meter per second towards the left side. It indicates that velocity of the B with respect to A. So A feels that B is approaching the approaching A with 30 meter per second. So approaching means actually A is left side is there, no. So B is approaching towards what here? Left side. That's why we got a 30 meter per second left side. I hope it is clear for you. The same manner, if you consider that there is a position of the two particles is A and B is there, the separation between them is, let us consider that x relative is there. Both are moving with like a VA and VB. Both are moving with constant velocities. In that case, if velocities are constant, in that case we can write it as x relative is equal to v relative into time taken t. You can write this relation, you can apply. Okay, let us consider one more point. If A and B both are separated by the certain distance x relative, the initial velocities are UA and UB. They are initial velocities, and their accelerations are AA and AB. Now you can see A and B are accelerating, actually moving with constant accelerations. Constant accelerations. If they are moving with constant accelerations, you can use the relations like this. V relative is U relative plus V is equal to plus AT. Next, X is equal to UT plus half AT square is there, no, that I am writing. Half into A relative into T square, and V relative square minus U relative square is equal to 2 into A relative into X relative, we can write. To calculate the velocity at any time t, this is the velocity at any time t, position or displacement separation at any time t, and velocity at any position, we can use these relations. Whether it is like a motion under gravity related questions or moving in a horizontal direction, you can use the these relations. Okay, later the same relations we can apply for the 2-dimension also. I hope it is clear for you. I am not going to give the much relations here. Why? Because we cannot remember much relations also. You should know how to apply only. I am moving to the questions part from the previous JEE mains as well as a little bit JEE advanced questions also. Whichever they ask till now in JEE mains and JEE advanced, some questions I have taken, you can see. The first question, a passenger train of length 60 meters travels at a speed of 80 km per hour. Okay, 80 km per hour is nothing but we can write it as 80 into 5 divided by the 18. You can get the value is this is 40 times and 9 times. You can get the 200 by 9 meter per second. Okay, next one, and another train is length is 120 meters. Travels at a speed of 30 km per hour. What is the meaning of 30 km per hour? 30 km per hour is nothing but 30 into 5 by 18. Why I am converting into meters? Actually, this answer they have given, length of the train is there in 60 meters and 120 meters. That's why I am changing this. So 18 is 9 times here, 15 times is there. We can get 75 by 9 meter per second. I calculate velocity of train 1 and velocity of train 2. Now you see here, both the trains, which direction they are moving. Okay, question they are asking. The ratio of times taken by the passenger train to the to completely cross the freight train. What is the meaning of freight train? Freight train means goods train. Okay, which actually brings the goods. No, the train name is called freight train. Okay. This is a freight train and passenger train, both are moving. If they are moving in same direction, one time you will get. If they are moving in opposite direction, one thing you will get. So I am writing like this. Let us consider the first train, passenger train. passenger train. This passenger train is moving with 80 meter per, sorry, not 80. We are getting the value is 200 by 9 meter per second, that I have taken V1. The length of this train is given that 60 meters. Okay. Now there is a freight train is located here. This is goods train. Freight train is nothing but goods. So we can see that this freight train. See, engine is located here. Let us consider this engine. This engine is located here. Okay. This freight train is moving with 75 by 9 meter per second. This distance is equal to, we can see, 120 meters. First passenger train is 60 meters. You observe this. To cross this, actually this passenger train moving like this. So it crosses nothing but actually this train should reach to this point. So how much distance it traveling, tell me now, to cross this. So you can see that it should travel a total distance of 60 meters plus 120, that is equal to how much? 180 meters it is traveling. So you can say that x relative is equal to 180 meters. Okay. Now what is the relative velocity? V relative value, if you see that, as both are moving like 200 by 9 and 75 by 9, both are same direction, you can write it as 200 by 9 minus 75 by 9, we will get the 125 by 9 meter per second. Now time taken, as they are moving with constant velocity, T1 can be written as x relative divided by the V relative. The T1 value is equal to 180 divided by the 125 into 9. So we can write it as 120. Next case, they both are moving in opposite directions. Now you can write now directly. This is 60 meters and one more freight train is there, which is 120 meters. Now to cross this, actually this train is actually both are moving like a V1 and V2 speeds. To cross this, when it will cross here, it should move left side, and passenger train is moving right side. So whenever it is crossing, we can see total length covered is how much here? 180 meters only again. So you can write it as 60 plus 120, that is equal to 180 meters. And we can write it as time T2 can be written as x relative divided by the V relative. As V relative value, you know that both are moving opposite direction, you can write it as V1 plus V2. That V1 plus V2 is 275 by 9 meter per second. As 275 you have to add. You can write the 180 divided by the 275 into 9. Now they are asking what is T1 by T2 ratios. T1 by T2 can be written as 180 into 9 divided by the 125 whole divided by the 180 into 9 divided by the 275. So we can see 180 by 9, 180 by 9 get cancelled, and 275 divided by the 125. 275 is 1125 and this is 525. So 11 by 5. Observe this carefully when they are moving same direction, when they are moving opposite direction. I have written, you can see. Opposite direction velocities I have added, same direction velocity is subtracted. Okay. Next question. Train A and train B are running in parallel tracks in opposite directions with speeds of 36 km per hour. 36 km per hour is equal to 36 into 5 by 18. That is 10 meter per second. Next, one more thing, 72 km per hour is there. That is 72 into 5 by 18. Value is 20 meter per second. Both are moving opposite directions. We can see a person is walking in a train A in the direction opposite to its motion with a speed of 1.8 km per hour. 1.8 km per hour can be written as 1.8 into 5 by 18. We can get the 0.5 meter per second. This is the velocity of A, this is the velocity of the B, and this is the velocity of a person with respect to A. This is the relations. Given values are this. We need to calculate the, there is a one more person is there observed from the B. Let us consider the person 1. Okay. Person B, actually it is at rest with respect to the B. P2 with respect to B is equal to how much? 0. Distance between the tracks is negligible. So both the trains are actually moving opposite direction. Okay, now I am drawing here. Let us consider this is a train. Train A is moving with an velocity of 10 meter per second. Inside this there is a person P1 is there who is moving with 5 meter per second. This is a velocity of the person P1 with respect to A. Okay, I am writing first velocity of the person 1 with respect to A can be written as velocity of the person minus velocity of the A. Velocity of the person with respect to A is 0.5 left side is there. P1 you don't know, velocity of the person 1. Velocity of the A is 10, right side is there. So we can write velocity of the person 1 is equal to 0.5 left side plus 10 right side is there. We can write it as 0.5 left side minus 10 left side we can write it as. So we can get the minus 9.5 left side will get. So finally I am writing, so actually correct only. So we can write it as minus 9.5 meter per second left side. This is the value. Next case you can see that how it is moving in the next case. There is a train B. Here person P2 is there. B is moving actually in opposite direction. Okay, velocity of the B is equal to 20 meter per second. Now velocity of the person P1 with respect to P2 is equal to how much? Velocity of the person P1 minus velocity of the person P2. Velocity of the person P1 is minus 9.5 meter per second left side. Person P2, actually person P2 with respect to B is 0. Person P2 value is equal to how much? Velocity of the B only, that is 20 meter per second left side. I am writing same thing, 20 meter per second left side. You can get the values minus 29.5 meter per second left side, or you can write it as 29.5 meter per second right side you can write. Either way you can write. So which of the following is correct? Second option is the correct option. Okay, I have written like a properly without using any vector notation, no, just left side right side I am using. Okay, I am not using I cap, J cap, K cap. Okay, next, two spherical balls having the equal masses with radius of 5 centimeter each are thrown toward upwards along the same vertical direction at a interval of 3 seconds with a same initial velocity 35 meter per second. See here, they are projecting with 35 meter per second. At the interval of 3 seconds means the second ball is there ready to throw and the first ball is reaching to the 3 seconds. This is what here t is equal to 0 part. Okay, it is ready to project. Now 3 seconds are there. How much value is there here? It is moving with what velocity? V is equal to u minus gt will be there. U value is 35. So we can say that 35 minus 10 into 3. We can see 5 meter per second is its velocity. Now you can see what is the gap between them. So in 3 seconds how much distance it travels? H is equal to ut minus half into gt square. U value is 35 into t is 3 seconds, half into g is 10 and t square is 9. We can see that 35 into 3 is 105 minus 45. 105 minus 45 is 60 meters. The gap is 60 meters. This is actually y relative. Y relative is this. And what is the a values? Here g is downward direction. For this also g is downward direction. We can say a relative value can be written as g downward minus g downward. So finally you will get 0. Nothing but a relative value is 0. So what is a v relative value? V relative value can be written as 35 minus 5, that is equal to 30 meter per second. Why? Because one is having 35, other one is having 5. Okay, so this is a V relative. As no acceleration, V relative will be constant. If V relative is constant, we can write it as T is equal to V relative X relative divided by the V relative, or Y relative divided by the V relative. Now y relative is 60 and v relative is 30. So that is equal to 2 seconds. Nothing but you can see that after this instant, 2 seconds later they will collide. Okay. Nothing but after above incident, above separation, 2 seconds later they collide. What is the meaning of they collide? Now you can see whatever the ball 2 is there now, it will reach to certain height. Ball 1 is actually go up and again come back. See, if you want, you can see what is the time of flight of this. If any body is projected with 35 meter per second, they will reach the time of ascent value is 3.5 seconds. Why? Because time of ascent value is equal to u by g is there now, you will get the 3.5 seconds. In 3.5 seconds only the ball is coming up top point. Again you can see that t is equal to 2 seconds. You have to see now this is t is equal to 5 seconds part, and for second ball, this is the first ball, second ball is coming to the same height here. This value is equal to much, t is equal to 2 seconds. Now this height we want to calculate. What is this height here? So for 2 seconds h is equal to 35 ut minus half gt square. 35 into 2 minus half into g is 10, no? T square is 4. You can see that 35 minus 35 into 2 is 70 minus 20. You will get the 50 meters is the answer. Okay. Now you can see answer is how much here? 50. Observe this carefully. They have not asked this much data, but you should know how the these bodies are moving, where they are colliding. Okay, two ball is going up, first ball is coming down. So from the ground they will meet at 50 meters. Okay. Next question. A stone is dropped from the top of a building. When it crosses a 0.5 meter below the top, another stone starts to fall from a 0.25 meter below the top. Both the stones reaches the bottom of a building simultaneously. The height of the building is. You see here from the top a ball is dropped here. This ball is reaching to the 5 meters. This distance is how much? 5 meters. It is dropped actually, u is equal to 0. Now whenever it is reached here, 5 meters is nothing but you can see the velocity of this body is v is equal to root over 2g into h. That value is root over 2 into 10 into 5. We can see that 10 meter per second is the velocity. Okay. At this time you can see one more ball 2, this is a ball 1. Okay, first one is ball 1 and second one is ball 2. At 25 meters below this, and means separation between them is how much here? 20 meters. This ball is dropped, velocity is how much here? 0. Now both balls simultaneously, the first ball and second ball, both are simultaneously striking the ground. Now question is, what is the height of this is how much? Okay, now you see at the time of releasing, the ball 1 is having 10 meter per second, ball 2 is having 0 meter per second, and separation between them is 20 meters. You observe this relative velocity is equal to, we can write 10 minus 0, 10 minus 0, then can be written as 10 meter per second, and relative separation y relative value is equal to 20 meters. Okay, and a relative value is equal to 0. Why it is 0? This is g downward direction, this is also g downward direction. A relative can be written as g downward minus g downward, so we can get the value is 0. If a relative is 0, v relative value is 0, that is constant. Okay, now you can write it as whatever the time taken is there, you can write it as y relative divided by the distance by velocity is, that I am writing. Y relative is 20 by 10, that is equal to 2 seconds. Nothing but the second ball in 2 seconds it reaches. Okay, how much distance it travels? H is equal to half into g into t square. So you can get the value is how much value is it? 20 meters you will get. Now total value, if you see that this is 25 meters and 20 meters, total 45 meters is the height. I am writing capital H. Capital H value is how much? 45 meters. You can take the 45 meters. Okay, all whatever the motion is straight line and kinematics questions are there, you need to understand the question write the given data, follow line by line instructions whatever they have given, apply what formulas is available for you. If you apply the same thing, you will get the answers. Okay. Next one, a car is standing 200 meters behind the bus, which is at rest. Okay, now you can see there is a car. I am writing this is a car, and there is a bus. Bus I am writing B. Bus is at rest. Car also initially they have not given. Which is also at rest means both are at rest initially. The two starts moving with the same instant but with different forward accelerations. Means initial velocity of car is 0, initial velocity of the bus also 0. Now car is moving with an acceleration of 4 meter per second square as per the question, and bus is moving with an acceleration of this acceleration of the car, acceleration of the bus is 2 meter per second square. You can see 2 meter per second square. The car will catch up with what? So separation is how much here? X relative value is equal to, they have given 200 meters. Now as both are moving in both are accelerating, you need to calculate at what time they will catch. So you need to write the x time relation you want. So x relative is equal to u relative into t plus half into a relative into t square. X relative is 200, u relative value is 0, so we can write 0 plus half a relative value is how much? 4 minus 2, that is 2 into t square value you don't know. You can get the 2 and 2 get cancelled. Final y a relative is 2, acceleration of the car minus acceleration of the bus, 4 minus 2 is equal to how much? 2 meter per second square. Okay, so we can write 200 is equal to t square, so t is equal to 10 root 2 seconds we will get. So here option is C. Okay, you need to apply whether acceleration is constant means you need to apply x is equal to t plus half a t square like that. Velocity constant means you can write x is equal to v relative into t. Next one, this is a JEE advanced question asked in 2014 paper 1. A rocket is moving in the gravity free space with a constant acceleration 2 meter per second square along positive x direction. The length of the chamber inside the rocket is 4 meters. You can see diagram also they have given. A ball is thrown from the left end of the chamber in the positive x direction with a speed of 0.3 meter per second relative to the rocket. At the same time, another ball is thrown in negative x direction with a speed of 0.2 meter per second right end relative to the rocket. Whatever velocities they have given 0.3 meter per second and 0.2 meter per second, both are with respect to the rocket only. Okay. Now rocket is nothing but with respect to chamber of the rocket. Okay. The time in seconds when two balls hit each other. Now I am redrawing the diagram. You can also observe this diagram properly. Okay. Now first I am taking, this is a ball 1, whatever this they are projecting is we can see a ball is projected, ball A. So ball 1, it is projected with a 0.3 meter per second. This is a v relative value with respect to the rocket. I am writing this is a velocity of A with respect to rocket. Now as rocket is moving in acceleration 2 meter per second square. Now this is also having acceleration of the A with respect to rocket is left side will be there. So we can write 2 meter per second square. Why? Because acceleration of the A with respect to rocket is acceleration of rocket A minus acceleration of the A minus rocket. A is 0, rocket is 2 meter per second square is there. We can get the minus 2 meter per second square. That's why I have written left side. Okay. Similarly, rocket B is there, no? That we can see this is velocity of the ball B with respect to rocket. That value is 0.2 meter per second, and its acceleration we can see acceleration of the B with respect to rocket is equal to much 2 meter per second square. This is a given data. Now we can see the separation between them is 4 meters. Now you observe this carefully. I am writing for ball A. Ball A. Ball A, you can see right side we are having 0.3 meter per second velocity, and left side we are having acceleration of A with respect to rocket is 2 meter per second square. Now force is actually acceleration is left side is there. We can say that is pseudo force also. Now this body as motion is there, velocity is there right side, it will go right side like this, certain distance it travel. After that it velocity becomes 0. Okay, if velocity is 0, after that what will happen? Because of the acceleration, it will move with left side again it will come back. Okay, first you will calculate how much distance it is traveling. So x is equal to, we can write it as ut plus half a t square. So we can write it as u value is 0.3 into t minus, I'm writing reason is the opposite direction of a is 2 into t square. How much distance is there now as per the question? How much distance they are moving, we need to calculate. Okay, suppose say I don't know what is the time it is traveling. If I don't want the time taken, just I will write the how much distance it is traveling. So v square minus u square is equal to, if I write the 2a relative into x distance, x relative, here I think v relative and u relative. This v relative finally 0. Okay, and u relative value I can write it as initially 0.3 meter is there, 0.3 whole square I will get. 2 into a relative value is how much? 2. X relative I can write. So if I write the 0.09 divided by the 4 is equal to x relative, I can get the x relative value is equal to 0.09 divided by the 4 value can be written as 0.02 and we can write it as 8 times is there 1. So 1 means we can write 25. So you can write approximately 0.0225 meters. This is very less only actually. You can see here this distance whatever it is traveling is very less only. Or if you don't want this relation, we can see when it is come to rest also you can calculate if you want to. You can see v relative value is equal to u relative plus a relative into t. We can write v relative is 0, u relative value is 0.3 minus 2 into t. We can write 0.3 is equal to 2 into t. So t is equal to 0.3 divided by the 2. We can get the 0.15 seconds. In 0.15 seconds only ball is coming to rest. If it is coming to rest, how much distance it is traveling? As per this relation, x is equal to 0.3 into 0.15 minus half into a is 2 into and t square value is 0.15 whole square. Now you can get the some value. Whatever, maybe this value 0.02 is there or whatever value is there, we will get very less value actually comparatively 4 meters. I calculated actually. You can see ut minus half a t square, if I get like a this value I am getting like a 0.0675 meters I am getting. It is traveling a distance of 0.0256. Okay, the value is very less value you are getting actually. If it is very less value is there, this value is negligible. Okay, now you can see this ball A is actually moving forward direction little bit and again come back. So whenever it is coming back now, because of acceleration, it will be almost all at rest only. Almost all rest. Almost all rest only. Okay. If it is almost all at rest, now you can see ball B is there now, that will travel this much distance. So how much distance it travels ball B? You can write it as 4 meters is traveling. If it is moving for 4 meter distance, we are going to calculate what is the value. Okay, so B is traveling how much distance, and similarly for A value also I calculated actually. You can see in first case I am getting like a S relative is equal to U relative into time taken t. The reason is almost all the ball is there only. So if it is there only, you can write it as t is equal to U relative is S relative is 4, U relative value is equal to how much? Okay, U relative is how much? 0.5 and 0.2 is there no. Now you can see what is the total distance is there. We can see both are moving opposite direction. We can write time t is equal to x relative divided by the u relative of A and B. X relative is 4, u relative value is 0.3 plus 0.2, that is equal to 4 divided by the 0.5. 40 divided by the 5 will get the 8 seconds. Why? Because A is almost at rest only now. Or this is one of the relation. This may be possibility is there. Next, one more thing is there in JEE, what they have done is anyway that body is at rest only, what they have considered is their acceleration value is almost all same is there. Okay, if here I have calculated what value you are getting. Suppose if leftmost body is at rest, then how much distance second body should travel? 4 meters with acceleration 0.2 of at square. If I calculate, I am getting 2 seconds. Okay, observe this carefully. You can get the B is traveling a distance of B travels 4 meters. Okay, and to collide the A. Why? Because A is almost at rest only now. That's what actually they have argued, and finally they given option for the both 8 seconds as well as 2 seconds. Actually, it should happen the 2 seconds. Okay, this is also possibility is there 8 seconds. That's why they have given. You can see whatever xb is there. Okay, xb is equal to ub t plus of ab into t square. 4 is equal to 0.2 into t plus of a is equal to a is equal to 2 into t square. If we calculate t value, we'll get the 2 seconds. Okay, for this answer they have given 2 or 8 seconds. Both they have considered, and no doubt they have given both. Okay, I hope it is clear for you. Next one, for an observer looking out through the window of a fast moving train, the nearby objects appear to move in opposite direction to the train, while the distant object appear to be stationary. Obviously, you can see whenever we are moving, nearby objects we feel that it is going approaching and it will go. If you see that any star in sky, any moon in the sky, otherwise very far any hill is there, you can see that that will be stay there only. Nothing but this is correct only, whatever they have given. If observer and objects are moving at velocities v1 bar and v2 bar respectively, with reference to a laboratory frame, means with respect to ground also you can say, the velocity of object with respect to the observer is v2 bar minus v1 bar. That is also correct only. But whether it is correct explanation or not, we have to see. The correct explanation is not that actually. Correct explanation is, what should be the correct explanation? The far objects are actually their acceleration and our acceleration with respect to any other frame may be different. Understand that? Same thing if you apply from any other planet, both are having like a different maybe different accelerations also. Understand that? That's why whatever v2 bar minus v1 bar is given, that is not the correct explanation. Okay, so second option is the correct option. I have taken one question from the Irido. A motor boat is going downstream, overcame a raft at A in tau is equal to 60 minutes later, turn back and after some time passed the raft at a distance of 6 kilometers from point A. Find the flow velocity assuming the duty of the engine to be absent. That's what actually given question. We can see whatever the motor boat is there now, that motor boat is going downstream, overcome a raft. This is my raft. Boat is there, the boat is going forward direction, moving forward direction in 60 minutes. Okay, now we can see raft is not having any separate velocity. Raft will move with velocity of water only. Okay, raft is moving with velocity of water only, that is velocity of river. What boat will feel? It travel forward direction. Why? Because initially whenever it is starting, raft is at rest. Okay, now boat is moving forward direction for 60 minutes, again it is turning back and coming back. By this time what boat will feel is raft anyway at rest only with respect to water. Whatever boat is there, velocity of boat with respect to river you are seeing. Okay, boat is having certain velocity, maybe 30 meter per second, maybe 5 kilometer per hour, maybe 10 kilometer per hour, some value is there. That is also with respect to river only. Now what boat will feel is raft is not moving. Okay, so I have traveled forward direction 60 minutes, so again I'm meeting the raft again in same 60 minutes, like that it will feel. Actually if you see actually what will happen, while moving forward direction, river also flowing in forward direction, it takes 60 minutes. While coming back, river is flowing forward direction, boat is moving backward direction. Okay, this is my river flow. Boat is velocity of boat with respect to river is backward direction is there while returning. So now boat will take the more time. Okay, that time will be almost how much here, 60 minutes only. Understand that boat feel that raft is at rest only. That is actually boat with respect to river I am telling. Okay, now we can say that it will turn back in how much time, 120 minutes. So it meet the raft again after 120 minutes. In this 120 minutes, the raft is travel a distance of 60 kilometers. I wrote here clearly, you can see raft is actually traveled 6 kilometers. I have written that 6 divided by the time taken is how much here, 2 hours time is there. 120 minutes is 2 hours. So finally you will get the 3 kilometer per hour. This is a very good question from the video. That's why I have taken this also. We can refer this also. I hope you enjoyed this. Next lecture I will explain regarding the graphs in one dimension motion. Thank you very much.